targeting gsap.2, we'll target the dot box element and then apply some properties. Let's change the opacity back to 1. Maybe apply a bit of rotation of 360, a border radius of about 50%, a scale of 1.25, and a duration of about 2 seconds. So now we have a box that over 2 seconds turns into a circle. Now, in order to be able to test all of these different methods, we have to target all of these different buttons that will trigger them. So we have to type out all of these query selectors and event listeners, which will end up looking something like this. This is simply targeting all the buttons by their class names. I'll most likely leave this block of code down below so you can just copy it. And the same thing goes for these event listeners. The only thing we're doing here is targeting the element and adding a click event listener, which will then just listeners, which will end up looking something like this. This is simply targeting all the buttons by their class. Type out all of these query selectors and event listeners, which will end up looking something like this. This is simply targeting all the buttons by their class names. I'll most likely leave this block of code down below so you can just copy it. And the same thing goes for these event listeners. The only thing we're doing here is targeting the element and adding a click event listener, which will then allow us to apply some gsap logic. Right with it. By their class names. I'll most likely leave this block of code down. will then allow listeners, which will, and the same thing goes for simply targeting. Buttons by their class names. I'll most likely leave this block of code down below so you can just copy it. And the same thing goes for these event listeners. The only thing we're doing here is targeting the element, adding a click event listener, which will then allow us to apply some GSAP logic right within it. This has nothing to do with animations. But we just have to make it happen in order to be able to visualize it all. And now let's start exploring all of these different GSAP. It's targeting the element and adding a click event listener, which will then allow us to apply some GSAP logic right within it. This has nothing to do with animations, but we just have to make it happen in order to be able to visualize it all. And now let's start exploring all of these different GSAP methods. The first one on the list will be the play method. And you can use a play on a specific animation. But never before actually we have stored an animation in a variable so that we can execute some methods on it. So this is the first time that we'll do it. You can not only run a specific animation once, you can also store to a variable just like you would with a regular by saying const animation is equal to, and then you attach it to this gsap.to function. Pretty cool, right? And now we can use that animation within these functions by saying animation.play. And you can immediately see from GSAP's IntelliSense how it works. It plays the animation optionally from the given start time. So you can just say animation.play and set to true to start playing it, or you can just play it from the 1.5 second mark. But keep in mind that when you reload the screen, we start the animation immediately, so it never finishes. So using play, we cannot replay from the start. We can just start playing it from the start or from the pause position. But now the animation is actually ended, so there's nothing more to play. So to be able to visualize this better, let's also implement the pause. It's super simple. Just say animation.pause. And now, if you reload and if you're quick enough, you can pause the animation at a specific point in time. Or play it. So now we can play with those two in order to see all the little bits of that animation. Once again, you can pause it, Finally, there's a very weird one, which is kill. Yep, you can kill the animation. So let's see how it behaves. I will restart the animation, and then all of a sudden kill it. It looks like it paused it, but actually what it did is it completely removed the animation. It stopped it, reset the internal state, and it won't play again unless you recreate it. So if we now try clicking play, nothing happens because the animation no longer exists. I also can't resume it, so those two buttons are now completely dead because killed them. And I even can't restart it because the animation doesn't exist. There is nothing to restart. So I would have to completely reload the page in order for all of these to come back. Then there's the yo-yo. So just say yo-yo, which will set the yo-yo value of the given animation. Setting it to true means that each time the animation repeats, it should switch its direction forwards and reverse. So just set it to true. And now if you click yo-yo, nothing really seems to be happening. But that's because we have to call it alongside a repeat. So the last method I want to teach you is the repeat method, which we can get access to by simply saying animation.repeat, and you can pass in the number of how many times you want to repeat the animation. In this case, let's do 2 to tell the animation to run 3 times total, initial plus 2 repeats. So if I save it, it'll play once, and if I click this repeat button at the top right, and then restart the animation, you can see that now it repeats a couple of times. But now, if I turn on the yo-yo, which means that it will go back and forth, I will also turn on the to repeat functionality, and I will then run restart. What will happen? course, is for it to be framework agnostic, so I think we'll be fine with just a bit of vanilla JavaScript. Now, first. say else. If we're not, past 500 pixels, you just want to remove a class name of show. So run button dot class list dot remove show. Perfect. And now by default, let's set the is floating to be set to false. Great. So now let's go ahead and test it out. Perfect. And now by default, let's set the is floating to be set to false. Great. So now let's go ahead and test it out. If I reload and start scrolling down, you can see that at 500 pixels down, this button will actually appear and it'll move a bit up and down like it's inviting us to click. It also has a yo-yo, so it looks that it jumps up and down.
ছয়ের ঘতে ওরা বলছে কোন প্রতিপাদন কোন একটার কি ব্যবহার করতে।
Navigation system. Right now we have just a basic bar, and if you try to click some of these buttons, nothing works, let alone animates. So let's do it together. Open up the Path Easy lesson and let's start implementing the solution. First things first, we have to import GSAP from GSAP. And now we have to ask ourselves, how are we gonna implement this animated underline indicator that smoothly moves the selected tab when clicked? Well, first things first, in this case, we'll have to select a couple of elements. There is a tab, an indicator, and a tab row. So since we're working with AGS, let's go ahead and grab all of these. We're saying const tabs is equal to document.query selector all, and then we can just target a dot tab right here. We can duplicate this 2 more times. For the second 2, we can just use a regular query selector, and we can call it indicator and target the dot indicator class name. And the last one will be a tab row, where we can query select a tab dash row. Perfect. So now we grab all the tab buttons, the moving underline, and the container that holds all the tabs. Now we have to create a function called update indicator. So I'll say function update. Indicator. That looks like this. Of course, if you want to, you're totally free to use the ES6 version of this, which would look something like this with an arrow function in mind. Both of these versions work just fine. Now, within this update indicator, indicator function, we first have to get access to the bounds of specific elements. So for example, we can get access to the bounds of the tab by saying tab bounds is equal 1.7 is the overshoot amount. The higher it might feel alive and it avoids stiff and robotic motion. Of course, you can switch it to my favorite, like power1.in-out, which will still be smooth, but it'll have no bounce, which is much less tactile. Yeah, you can see the difference, right? It kind of feels a bit slow and sluggish. You could also try the bounce and take a look. This one, yeah, it bounces, but it bounces in place and it looks a bit unnatural. So this back out is definitely the best easing function to implement for this indicator animation. Great job. Okay, let's go ahead and build this tabbed navigation system. Right now, we have just a basic bar, and if you try to click some of these buttons, nothing works, let alone animates. So let's do it together. Open up the back easing lesson, and let's start implementing the solution. First things first, we have to import GSAP from GSAP. And now we have to ask ourselves, how are we going to implement this animated underline indicator that smoothly moves to the selected tab when clicked? Well, first things first, in this case, we'll have to select a couple of elements. There is a tab, an indicator, and a tab row. So, since we're working with plain.js, let's go ahead and grab all of these by saying const tabs is equal to document.query selector all, and then we can just target a .tab right here. We can duplicate this 2 more times. For the second 2, we can just use a regular query selector, and we can call it indicator and target the .indicator class name. And the last one will be a tab row, where we can query select a tab-row. Perfect. So now we grabbed all the tab buttons, the moving underline, and the container that holds all the tabs. Now we have to create a function called update indicator. So I'll say function update indicator. That looks like this. Of course, if you want to, you're totally free to use the ES6 version of this, which would look something like this with an arrow function behind. Both of these versions work just fine. Now, within this update indicator function, we first have to get access to the bounds of specific elements. So for example, you read about it, elastic easing creates that
bouncy, spring-like motion that overshoots and oscillates before settling into place. It mimics the effect of pulling and releasing a rubber band, making animations feel dynamic and playful. There are different variants like in, out, and in, out, which controls when that bounce occurs. So here's a challenge. In front of us, we have a chart of sorts. So let's explore where is it coming from. Right here within this index.html, you can see that the only thing we have is this repeat button, as well as a div with an ID of chart. Then, if you head over into style.css, you'll be able to see that this one has a few more styles than usual, because I needed them to create this nice looking chart from scratch. And then, if you head over into the script.js, you'll be able to see the starter code of this lesson. All of the code right here has absolutely nothing to do with GSAP. It is all about rendering and modifying the chart. But right here is where the GSAP animation will go. So let's quickly go through it. We're first selecting the repeat button, so we can later on attach some functionality to it. Then we have some sample data for each day of the week. For example, 80, 60, 100, 70, and so on. You can think of these as really any kind of data points that we can work with. After that, we are getting the reference to the chart container, and then we're calculating the layouts by getting the current height. We set the bar width and the spacing, and the value of all of those points, so we know what is the maximum value that exists. And then we are ready to start rendering the chart by creating a new bar, giving it a specific number of pixels, and then we start creating the bar for the values by first deciding its width, and after the width, we need to define its height, which is the actual value that we want to display. So we're doing that here. And then finally, we attach a label to it and assemble those components by appending different children to it. But now is the time that we actually animate it. Here, we can first import GSAP at the top, and then we can use our good old GSAP.do, where we can target each individual bar, and want to animate each one of those bars by giving it a scale, y, of 1. If you do that, immediately, you'll start seeing those different bars pop up on the screen. Let's increase the duration so they happen over a longer period of time, like 1 second, or maybe even 2. There we go, so now they're nicely filling in. And finally, we're going to use elastic easing by saying ease elastic.out. And then you can even pass some additional numbers, such as 1, which is the number of bounces, and then maybe we can do 1.25 for how far it overshoots, giving it a springy, natural effect, like a bar bouncing in place. So if I save this, you can now see that it jumps up a bit and then comes down. If I increase the number of bounces to something like 10, you can see that now it jumps out so much more. And finally, we can play with a staggered delay right here. Whenever you have an array of elements, well, that's a good place to introduce a stagger. So I'll add a delay to each one of the elements of, you could just add like 0.1 second, or you can increase it to maybe like 5 seconds, and then all of them would start happening after 5 seconds, because they're all part of the same animation. But if you take the index of the bar that we're currently trying to animate, because we are right here within a for each loop, if you take an index and then multiply it by like 0.5 seconds for starters, you'll see that after each 0.5 seconds, a new bar will appear. But you never want to be too aggressive with animations, making them take too much time, so we can just drop it down to like 0.1. So now they nicely appear one after another. And I've also added the click event listener to the repeat function, so it re-renders the chart. So whenever you click it, you can see all of those bars just pop into place one more time with this elastic effect. This seemingly very simple animation will make your static chart feel dynamic and interactive, because each bar will grow elastically, guiding the user's attention. And you could try out some other easings. For example, bounce.up instead of elastic. You can see this one is much more exaggerated and might not feel good for a professional application, but if you want to go crazy with it, well, be my guest. You can also use something a bit more regular, like power2.out, for example. And you can see that here, it's just a bit more natural. But I really like the elasticity for the charts. And if you take a look at any kind of popular charts libraries, you'll notice that they use a very similar type of easing. The more you understand the behind the scenes of these animations, the more you will start seeing them as you browse the web. Great work. Let's dive right into the expo easing, which creates dramatic animations that start or end extremely fast or slow, mimicking exponential acceleration or deceleration. It's perfect for those effects that need a powerful burst or a sharp, smooth finish. Expo in begins slowly and speeds up rapidly, ideal for building tension, while the expo out starts with a burst of speed and then slows dramatically, perfect for those clean, tech finishes. But if you want to combine both, well, you'll have an intense cinematic feel. For this challenge, the goal was to create a little pop-up animation that shows you different tools that you can use from this single floating button. That button is contained right here within the index.html. You can see it right here as a plus. And then if you want to choose your topping on the pizza, well, donuts might not be the best topping to choose, but hey, here you go. Well, then it needs to show up right here have some styles right here and different colors for all of these buttons. And then within the script, we have a simple starter. As usual, no GSAP logic here so far. We're mainly just setting up our workspace. So we're selecting the buttons and the children. We're setting the radius of how far children we want spread out from the center. And we have a variable to track whether the menu is expanded or collapsed. Then we have an event listener that happens on click of the button, which changes the button from a plus to an X. You can see that's working already. But then, if it's expanded, we want to define how or where those additional buttons will pop up. So here, I asked ChatGPT to do a bit of math for me. Since we're working in a circular shape, they're going to appear here, here, and here around this button. We are using a bit of radians or pi formations, but that's not something we have to worry about here. We have to worry about actually animating those buttons to pop up. So once we actually calculate the angle of where we want to make them show up, we have to animate them to pop up and then animate them to go down. So let's focus on that right away. Okay, to animate it, we first have to import GSAP from GSAP, and then we can start using it right here by saying GSAP.to. We're going to target a child element, and we want to start animating its X and Y position. until we reload. For now, when we try to collapse it, maybe we can just run gsap.to. We're gonna collapse a child with a property of x0, y0 to bring it back, and then an opacity of 0 as well. For now, this should be good enough to just hide it. Perfect. But this is bit deeper into a method that we have used most often in this entire course. It is the gsap.to method, used to animate the elements from their current state to a new state. We'll learn it on an example of animating a toast notification. So, to get started, head over to Pages and find the Learn To. You'll see that I added some simple HTML, which just contains this toast notification. And then in the styles, I simply styled it in a simple way. But then, where the magic happens is within the script. Now, if you head to our current application, you'll notice that right now it is completely static. So one thing that I want to start with is just modify some default styles to -100px, which will move it off the screen. And then I also want to change the opacity to 0, because now within the script we'll animate it. Show toast loop, because it'll loop it just so we don't have to repeat it every now and then. And we can just open up a new function within which we'll do the animation. So you could have totally just said gsap.to right here in the global object. But in case you want to reuse it, then it might be good to put it within a function. So I'll make a function call as soon as the application show toast. And then within it, I want to start animating it by saying gsap.to target the.toast. And then, first of all, move its Y position to -120. This will move it upward. And don't forget to change the opacity to 1. Immediately, it'll pop up. Now we can also modify the scale to something like 1, because initially, if you check out the styles, you'll see that its scale is set to about 0.95, so a bit smaller than 1. So if we increase it to 1, it's going to make it appear like it's growing as it's coming up. We can also change the duration to like 0.8 seconds to make it slowly appear, or in this case I would say emerge. And you can... Now let's dive a bit deeper into a method that we have used most often. Use the easing. But we've covered gsap2 so many times, so in this lesson, I want to teach you something extra. Every single gsap method comes with something known as callbacks. All tweens and timelines have different callbacks. A quick look at gsap's documentation page on callbacks will show you there are quite a lot of different ones, like on complete, on start, on update, on repeat, and on reverse complete. And the way you call them is you simply pass them as an additional method, as a property to one of the methods you've used before. Let me show you how that works in action. For example, when you want to rerun the animation at the end. So in this case, use the on complete callback, and then within it, you want to say what you want to happen once this animation completes. Such as maybe you want to apply an additional animation by saying gsap.to. We can once again target the toast, and then apply a delay of about 2.5 seconds. And then here, we want to pause the animation by applying a delay of about 2.5 seconds, which will make the toast stay on the screen for about 2.5 seconds. And then after that, we want to slide it out by setting the Y to 0. We want to change the opacity back to 0. We also want to change the scale back to 0.95 throughout a duration of about 0.7 seconds, with an ease of something like power2.in. So if you save it, it's going to come up, wait about 2.5 seconds, and then it's going to hide itself. The use of gsap2 and the on-complete callback is the perfect use case for how toasts typically work. They show up, they tell you that you have about 99 problems, and then they go away. And if you want to, you can even chain the callbacks. So if you want to apply a callback to this gsap2, you can totally do that by saying on-complete. In this case, we just restart the animation after a slight delay. For example, by calling a regular JavaScript method of setTimeout, which will recall this show toast loop after a specific number of milliseconds, like 2.5. So now if we save it, it's going to be here, it's going to go away, and after 2.5 seconds, it's going to repeat. And with that, you learned how to use the gsap2 method. Technically, you've known it for this entire time. let's dive a bit deeper into a method that we have used most often in this entire course. It is the GSAP. In this lesson, let's talk about GSAP's dot-to twin method, the dot from. It's used to animate elements from a new state to their current state.
Try your best to understand.
স্টার লেখাটা তুমি লাল কালারের মধ্যে দিচ্ছ, যে ব্যাকগ্রাউন্ড ওইটা লাল কালার ছাড়া অন্য কোনো কালার একটু দিয়ে দেখো না। লাল কালারটা মানে দেখতে কিরকম লাগতেছে আর কি। হোয়াইটের মধ্যে সামান্য অ্যাশ কালারের মধ্যে ওই স্পিড স্টার ডিজাইনটা করো একটু। হোয়াইটের মধ্যে সামান্য অ্যাশ কালারের মধ্যে ওই স্পিড স্টারস ডিজাইনটা করো একটু। ব্যাকগ্রাউন্ডটা ব্ল্যাক কালার করে দাও।
And we can change the Y position to something like
have something known as a sequential reveal, which means that card 1 will appear first, then card 2, and then card 3, creating this pleasing visual rhythm. is not, because this is not a class name, it is type name. Vent individual. By pressing the wheel, you'll be able to see this animation multiple times. Pretty cool, right? Now you know not only how GSync.2 works, but also where the GSync got from. Great work.
Take my hand, don't let go.